Hello, I'm David Altenhofen.
And I'm John Killian.
And today we're going to take a look into op-amp circuits,
which are very useful, so pay attention.
We will kick it over to John quick to explain our setup for our op-amp circuit in PSpice.
Thanks, David. Now, we all know that the gain in a non-inverting amplifier is the sum of the two resistors over R1. So in this case, 1100 over 100, so a gain of 11. The green probe is the output and the red probe is the input. So the green probe should always be 11 times greater than the red probe. When we run the simulation, as you can see, it is approximately 11 times greater. And it's not exact opposite because it's not inverting. So everything checks out and it looks like our op-amp is working correctly. We use the DAC to measure the voltage across the 1K resistor and the 100 resistor, and we built an XY graph comparing those two values, and then we split the two data streams from the DAC and sent them to a curve fitting program, which we used to find the slope, and the slope in this case is the gain.
So now it's time to look at the nitty-gritty part of building our circuit for testing our op-amp device. So enjoy the show. For our setup for the op-amp, we started out first by connecting our power supply to the VCC of the op-amp. Then we connected our positive 20 voltage side to our VCC plus, and then we connected the negative 20 volt output to the negative VCC. We then used the function generator as our source supply for our circuit. We used the DAC to measure the voltages across the 100 ohm resistor and across the 1000 ohm resistor so that we can compare the two voltage drops and find out our gain for the op-amp circuit. So here we have our output graphs from our DAC readings of the voltages across our R1 and R2. As you can see from the graphs, this is a non-inverting amp-op setup because both graphs peak at the same point and they are not set up opposite like they would be in an inverting circuit. And then on the bottom you can see our graph of our two amplitudes plotted versus each other in an XY graph, and this line, the slope of it, represents our gain from our op-amp, which is slightly over 10.
Now some might wonder what happens if you take out the feedback resistor. Well, I'll do that for you just so you can see.
PSpice? No, in like our actual record.
I don't remember. Ta-da! The V out becomes V in. As you can see, the points are right on top of each other and they follow so closely together that you can't actually see the V out graph.
Thank you for tuning in to this week's edition of op-amps.
Next week, we'll look at active filters.
See you then.